Look at some application problems, the solutions to which involve systems of equations. Written over here on the board are blueprint for problem solving. The only change in the blueprint is this. When we get down to this step 3, reread the problem and write a system of equations that describes the situation. Step 4, then we would solve that system of equations. Everything else in the blueprint for problem solving stays the same. So we're going to assign a variable x to one of the unknown quantities and the variable y to the other unknown quantity in these problems, and then based on that we'll write a system of equations that describes the situation. Let's look at our first problem. Two positive numbers have a difference of 5. The larger is 1 more than twice the smaller. Find the two numbers. So what I'm going to do is this. I'm going to say let x equal the larger number and y equal the smaller number. Since we have two numbers that we're looking for, we can use two variables now because we know how to solve a system of equations in two variables. Now, two positive numbers have a difference of 5. So the difference is 5, and I'm going to take the larger number, subtract from it the smaller number, and that difference I know comes out to be 5, and I know it's positive 5 because I've assigned x to be the larger number. Now, second, I have this. The larger is 1 more than twice the smaller. So the larger number x is 1 more than twice the smaller number y. So x is equal to 2y plus 1. So you can see here I have a system of equations. X minus y is equal to 5, x equal 2y plus 1 that describes this situation. Now, a lot of people solving application problems seem to feel that solving application problems using systems of equations is a little easier than the way we solve them using just one equation in the previous chapter. And that's because you have two variables. So if you have two unknown quantities, let x be equal to one of the unknown quantities and the variable y equal to the other one. Then you can organize your problem into smaller little segments. Take part of the problem and write an equation. Take another part of the problem and write another equation. Now you can see that this system of equations lends itself very well to solving by substitution. I won't solve it, but if you do, you would use substitution to solve this system. I just want to set these problems up for you. Let's look at our second one. A woman invests 4 times as much money at 5% as she does at 6%. The total interest for the year is $520. How much is invested at each rate? So we want to know how much money is invested at each of the two rates. So I'm just going to say, let's let x equal the amount invested at 6%. I could have said 5%, but I just said 6%. And I'll let y equal the amount invested at 5%. Now, I have x equal to one of the things that's asked for in the problem and y equal to the other thing that's asked for in the problem. Now I'm going to go back and read the problem again and see if I can find two equations that together describe the situation. So, first of all, a woman invests 4 times as much money at 5% as she does at 6%. So the amount of money invested at 5%, y, is equal to 4 times the amount of money that's invested at 6%, x. So 4 times as much money at 5% as invested at 6%. So the amount of money invested at 5% is 4 times the amount of money invested at 6%. So here's one equation in my system. The total interest for the year is $520. Well, she has X dollars invested at 6%, and so the interest earned on that X dollars at 6% is 6% of X. So 0.06 times X plus the amount of interest she earns on the money invested at 5% is 5% of that amount, or 0.05 times Y. The total amount of interest that she earns from both accounts is $520. So here is my system of equations that I can solve for x. Y equals 4 times, that I can solve for x and y. Y is equal to 4 times x, and 0.06x plus 0.05y is equal to 520. Again, a system that looks like it's solvable by substitution pretty simply. This second equation, I might decide to multiply both sides by 100 just to clear it of decimals to begin with. But in any case, that's going to be a pretty easy system to solve. Let's go on and look at the next problem, which is a coin problem. Tom has 21 coins totaling $3.45. The coins are dimes and quarters. How much of each type does he have? So I have two different types of coins, dimes and quarters, and I want to know how many of each type I have. So I'm going to say, let's let X equal the number of dimes. Then I'll let Y be equal to the number of quarters. So X is the number of dimes and Y is the number of quarters. Now, Tom has a total of 21 coins. Well, the coins are all dimes and quarters, so the total number of coins is the sum of X and Y. So X plus Y is equal to 21. So this tells me that the total number of coins is 21. Next, the total value of the coins is $3.45. Well, I have X dimes, each one of which is worth 10 cents. And I have Y quarters, each one of which is worth 25 cents. So I'm going to say 10 cents times the number of dimes plus 25 cents times the number of quarters is going to come out to be the total amount of money I have, which is 345 cents. And I'll do this in cents rather than dollars and cents so that I can avoid writing a decimal down. So the total coins, 21. That's X plus Y equals 21. The value of the coins, $3.45. And that comes from 10 cents for every dime and 25 cents for every quarter. Now, this looks like a system of equations we could solve pretty simply by using the elimination method. Maybe multiply this top equation through by negative 10 so that I could add it to this and eliminate the variable X. But again, I just want to set it up for you here so you can see what the system looks like that describes this situation. Let's look at one last problem. How many liters of 50% alcohol solution and 20% alcohol solution must be mixed to obtain 18 liters of 30% alcohol solution? Well, I'm asked for the number of liters of 50% solution and the number of liters of 20% solution. So I'm going to start by saying, let's let X equal the number of liters of 50% solution. Now, a 50% solution means that 50% is alcohol and 50% is water. Then, I'm going to let Y be equal to the number of liters of 20% solution. Now, how many liters of 50% solution and 20% solution, alcohol solution that is, must be mixed to obtain 18 liters, that's 30% solution? Well, I want to end up with a total of 18 liters. So I'm going to mix X liters of 50% solution and Y liters, that's 20% solution, and I'm going to end up with exactly 18 liters. That gives me my first equation, which is X plus Y is equal to 18. So this is for the total number of liters in the problem. X liters of 50% solution plus Y liters of 20% has to come out to be the 18 liters I end up with. Now next I'm going to look at the amount of alcohol in each solution. This X liters that's 50% solution, half of it is alcohol. So the amount of alcohol in that solution is 0.50 times the number of liters of solution. This Y liters that's 20% alcohol, only 20% of it is alcohol, so the amount of alcohol in that solution is 20% of Y. Now that has to come out to be a 30% solution, and I have 18 liters of it, so the amount of alcohol in that 18 liters is 30% of 18. So in a problem like this, I look at the total number of liters, and then I look at the total amount of alcohol in the solution. 50% of this X liters and 20% of this Y liters are alcohol. So if I add the alcohol here to the alcohol here, I have to end up with the total amount of alcohol in the final solution, which I know should be a 30% solution and is 18 liters. So 30% of that 18 liters is going to be alcohol. So that's a variety of word problems, the solutions to which involve finding a system of equations that together describe the situation in the problem.